Hello viewers, welcome back to our YouTube channel, and today we want to look at the stem and leaf diagram. Of course, this is our series to do with quantitative techniques. That is a CPA level 1 paper, and we want to look at our last chart that we can use to represent data. And of course, this is more of a diagram showing how data can be represented using a diagram or a graph. We have seen several. In the previous video we looked at the box and Wixer plots, and we've been able to illustrate that, and today I want us to understand how we can be able to get to draw a stem and a leaf. It is called a stem and a leaf, a stem and a leaf diagram, or a stem and leaf diagrams. So we want to understand how can I represent data using a stem and a leaf diagram. First off, a stem and a leaf diagram is one of the powerful ways to present data, because it provides you with the individual values. It provides you with the individual values while displaying the overall distribution. It gives you individual values, and as well it provides an overview or overall distribution. In other words, the individual figures are not all that manipulated. It shows you the individual values, and as well showing you how the distribution is, or how those individual values are distributed. So it makes it very easy for you to be able to compute what you call the range. It makes it very easy for you to compute the range. You can as well be able to compute the median and the mode. But above that, it also shows you the clustering of the data points, or of the data points. So it is useful specifically when we are dealing with data sets that are maybe 10 to 50 values. If we are dealing with at least 10 to 50 values, where the details of each of the individual item matters most. So we use the stem and leaf because we want to have a detailed analysis. So we want to have a detailed analysis of the distribution, not necessarily on how broad the trends, maybe the trend looks like. So it focuses on getting information about the individual items, where, so if you are looking at the kind of information or at the kind of data, but the details matters more than the broader trends, then it's better to use a stem and leaf plot or a stem and leaf diagram. So the stem and leaf diagram or a stem and leaf plot is of course a method of organizing data and is a combination of sorting but at the same time graphing. So you sort the data set and then you graph the data. So one of the advantages that this stem and leaf plot or diagram has over the group frequency distribution, all these other frequency distributions that we have been having, is the fact that it retains the actual data, which I call the individual values. So it retains the actual data while showing you the graphic form of how that data can be represented. So it gives you two things. It sorts and maintains the original data or the actual data while showing you how it can be graphed, or it gives you its graphical form. And it's a very easy type of graph to construct than any other, whether frequency distribution or a histogram, because for it generally displays more information as compared to these other items. We are going to look at the steps and then we understand how we go about drawing it. So with a stem and leaf diagram, we think of each observation as a stem and a leaf. So we look at the different observations or the different items that we have, the individual values that we have as a stem and a leaf. So they appear, one individual value has both a stem and a leaf. So in general, the stem, these stems, because we've said it looks at each individual value, we look at it as a stem and a leaf. Whereby if I have, let's say, an individual value called 12, even if it is just 2 or 1, whichever the values are. Now, in the general term, we look at the stem. A stem can be more than 1 digit, more than one digit, or it can be more. It's actually, it can be 2, it can be 3, depending on the data set that you have. So a stem has many digits as may be required based on the data set that has been given to you. But a leaf, this is how you get to differentiate the two. But a leaf has only one value. A leaf has only one value or one digit. So that's one of the difference, that we can have as many stems or as many stem values in a given individual value that has been given to us. You can have as many as possible for stems, but the leaf is just only one digit. So a stem and a leaf is a data plot that uses part of the data values or part of the data value as a stem and part of the data value as a leaf to form what we call groups or classes. So definition wise, if you want to talk about or if you want to define what a stem and a leaf diagram is all about, we can say that a stem and a leaf diagram is a data plot that uses part of the data value. I'm talking about data value because I'm meaning one individual value. Data value as the stem and part of the same data value as a leaf, meaning in one value we have both the stem and the leaf, but they combine to form what we call a class, or they form classes or groups. Data value as the leaf, part of the data of the same data value as the leaf to form groups. You can call them groups or classes. That's definition wise. And we have said that the stem and leaf shows the first thing that it shows what we call data presentation. It does the presentation of data. It's one of the methods or the graphs or the diagrams that we can use to represent data, unlike the histogram, because we always compare, and most of the times you'll find questions that are telling you or that are requesting you to give the advantage of using a stem and leaf as opposed to a histogram. So we always compare it with a histogram. So unlike the histogram, the stem and leaf diagram provides original data, and these original data or the original values, data values, they remain visible to the reader. Then of course the other thing that it shows us, it helps us to get the distribution shape. We get to know how the data is distributed. The shape, is it a normal population, or is it showed in maybe in a a barrel shaped, like the one that we have for normal distributions, or is it skewed? So it tells you, it gives you the distribution shape. So the diagram resembles a sideways of the histogram. Of course, it is able to show clusters and then the gaps within the data that has been given to us. Then the other thing that it gives to us, it tells us the range. It tells us, it can help us to get the range. And we said the range is all about the smallest and then the largest values. Of course, these largest, of course, they are the ones that are going to be the maximum values, and then the smallest, they are the ones that are going to be the minimum, the minimum values that we have in the data set. The other thing that we can also get from a stem and leaf, it can also help us to get the median. The median, of course, the median is just that value that is going to be located in the middle of the actually it is in the middle of the leaf. That's where we are getting the median values. Of course, we found them, we can find the mean by looking at or by locating the middle leaf where the values are going to be ordered. Of course, when we look at the steps, we shall understand that we actually arrange this data depending on the smallest to the largest. So we use an ascending order, just like the way we talked about when we are dealing with a box and Wixar plot. Of course, the last item that it can help us to get is the mode. Of course, mode looks at the number that repeats itself. Now, for the stem, we look at the stem. We are going to see, we look at the stem, and then we check now the leaves. We check the leaves. Of course, if it is a leaf, this is the singular form. So we look at the leaves, and then we look at the repeated leaves. They are the ones that are going to give us the mode class or the model group, because the mode looks at the number that has appeared more times, or the one which has appeared more frequently. So the reason as why I'm providing some of these analysis is to help ourselves to understand that we can use these diagrams to actually interpret data. We can use these diagrams to find out or to answer some questions that may come, because they may give you a question, they tell you construct a stem and leaf, then the following question they may ask for you to get the range, to get the median. So these are some of the things that I'm highlighting out, and the other aspect is that I'm highlighting them out because when we are done with this topic, the next topic that we are going to start with, it is going to be the measure of central tendency, where we are basically going to be looking at the mean, median, and then the mode. And once we are done with that, we go to the measure of dispersion, or how data is spread away from the middle point. How is the data spread from the mean? We shall be looking at the measure of dispersion, where we shall be able to compute the interquartile range. So I just want to create a narrative that these topics are interconnected. So you are not going to just read each of these topics in isolation. get to understand the concepts, but also know how they link into other topics. Because it is very important. Once you get that, then it will be very easy for you to follow along, and then you'll be good to go. So without taking much of the time, let's look at the steps in the construction. The reason as why I'm giving the steps is at some point there are those maybe who are doing it maybe at the university level. They may ask for you the steps. They might give you a theoretical question regarding on the steps. So steps in constructing a stem and a leaf. Sometimes they use hyphen. Some books you may find when they are writing stem like that, then they put a hyphen, and then they put a hyphen and they say a leaf. So whichever way, just know we are a stem and a leaf diagram. Sometimes they call them diagrams, or they may call them plots. Either way, they mean the same thing. And one key thing you need to get with this is that it keeps its original data, and it makes sure that each individual value that has been given to you has both a stem, or it has stems. Stems can be many, and it has a leaf. A leaf is just one digit or one value. So the stems can be more than one, so it can be many digits depending on the data set that has been given to you, but a leaf is only one digit. So we take note of that. So let's look at the steps. Of course, we spoke of arranging the data in an ascending order. So what we are going, our first step will be to arrange the data in order. Which order? Of course, most of the times, if you look at different textbooks, some textbooks may not give you this as the first step. Of course, arranging the data in an order is not so much essential, but I'm going to show you how it's really important to do so. So arranging the data, it may not, in some textbooks, it may not be your number one step in drawing a stem and a leaf diagram, but it is very important. Because if you don't do that, and maybe you are looking at the data set that is very large, maybe it is exceeding 50, maybe they are exceeding 50, because we say that the stem and leaf is good for data set that is maybe between 10 and 50. Now, what if I have 100 individual values? So it is very helpful when you are constructing a stem and leaf to organize the data first, because we've said that we need to make sure that the stems that we have are going to be ordered in some way, or in a sequential way, whereby we have arranged. Preferably, we can arrange in the ascending order, but even if you arrange the data set in the descending order, as long as there is some kind of ordering, because we want the leaves in the final stem, and of course the leaf plot should be arranged in some order. It's most importantly with the leaves, because if they are not arranged in a certain order, then we are going to find that the data is going to be not representing the individual values, yet this is what it calls for. So a display can be made by using what we call the leading. When you are drawing the stem and leaf, we have what we call leading digits. The leading digits. And of course, these leading digits represent the stem. And we also have what we call the trailing digits. And of course, these trailing digits represent what we call the leaf. Represent the leaf or the leaves of that given data set. So we've said that the leading digits represent the stem or the stems, because I said this can be many digits. So we are going to have, actually for the trailing, we said trailing digit because it's only one. This one we say it is just a trailing digit because we said the leaf is only one digit, not a number, but a digit. So I want you to look at when we are talking about the stem and leaf, you have to understand that whenever we are talking about maybe one number, if we are talking about one number or what we call the observation, because an observation is that individual item. If it's a number, then it will be that individual value. So if I have a 2, that's my individual number. It's 2. If I write this number as 02, this number will be meaning the same thing. But if I put the 2 on the right side, it will change because then it will be a 20. But 02 and 2, these two values are the same. Now, the leading digit, because these are just only two numbers, so one of them is a stem, and then the other is a leaf. Now, the first digit is the one leading, like it's the starting point. So in here, we don't have any number. If you just have a 2, we don't have any number. So it means the leading digit is actually a 0. But you will see that when you have 0 as your leading digit, most of the times we don't write it, because writing 02 and someone writing 2, they mean the same thing. But the implication is that we have a stem as a 0, then a leaf as a 2. If I have an observation that has 3 digits, the big question is, what's going to be my leading value and what's going to be my stem. The stem or the leading value, if I have, let's say we have 2, 2, we have 2. Remember we said that the stem can be many digits. In other words, we can have leading digits. then one trailing digit. So these first two, because they are the ones leading, this is a stem. Then this last digit is actually the leaf. So my leading value is a 2, 2. Then if I just put maybe a line just to separate those two, this will be a leading value. Then this is my leaf of 2. So if I combine these values, it will be, if I just remove this slanting line, it will be 2, 2. If I had this and it had maybe 4 digits, I'm dealing with maybe 4, 4, 3, 4, 3, 2, 1. So these first 3 digits will actually be the stem, then this one will be my leaf. That's why we said that on each individual item, we have what we call a stem and a leaf. Even if it is just 1 digit. 1 digit means that it's a leading, its leading digit is a 0. And most of the times the 0, most of the times we don't write it. Because writing it as maybe 01, 03, 04, it is the same thing as someone just writing a 4. But if you are given 1 digit, it means that's a leaf. That's not a stem. Because if you write it as a stem, this is what is going to happen. If I have 02, my leading value would be 0, my leading digit. Then my leaf will be 2. Now the difference is that if I choose to say that I was given 2, and instead of adding the 2, I choose this I choose, if I was given 2 and then I put the 2 here as a stem, the implication, even if I don't put a figure here, the implication would be that this is actually a 20, meaning this one would be a 0. So are you seeing that this is a 20? And yet the individual value that was given to you was a 2 or a 02. Or it was just a 2. So if you write it this way, it will be wrong, because if you combine this 2 and this 0, it will give you a 20. Yet the individual value was just 2. That's why when you are combining now this and this, it will give you a 0 and a 2, which is the same individual digit that was given to you in the question. And that's what we said, that for a stem and leaf, it maintains its original data set that was given to you in the question. I'm taking more time to explain this because I know it is very important. And this is all that you need. The rest is not so much important. But if you understand this, then you have understood even how to construct it. Now, the first one was to arrange the data set. The second step is to write the stems. We are saying stems because we said that these can be many. Stems from smallest to largest in a vertical column. A vertical column to the left. It's very important, to the left of a vertical line. A vertical line. You can call it a vertical line or vertical rule. The vertical rule is that we just put a column. You know, columns, they move downwards. Those are the columns. So that's what I explained. Of course, the third step is for us to write now the leaf. To write each leaf, because we said it is only one digit, each leaf to the right. The other one was on the left, then this one is going to be on the right. On the right of the vertical rule. On the right of the vertical rule. We have said to the right of the vertical, the right of the vertical rule, to the right of the vertical rule, the vertical rule in the row that contains the appropriate stem, Remember, the second step was for us to write the appropriate stem on the left. Now, in the same row, we write on the right hand side, or on the right side of the vertical rule, we put what we call the leaf, but it has to be in the corresponding row that we wrote our stem. Then the last one, of course, this is not so much important, because if we had arranged the data, then we wouldn't actually need more of this last observation. But one thing that you need to note is that this data set has to be arranged. So we arrange the leaves. Now I'm talking about the one at the right hand side. The leaves. I've told you this is just the plural form for leaf. In each row, the leaves in each row in an ascending order. You will see what I'm talking about. But once you arrange the data set in the first step, then this one is automatically covered. But you will see the difference, because you may arrange your data, then when it comes to picking the data, you pick it wrongly. Even though you had arranged it, you can pick it wrongly. So we are going to see how this last step appears. Because we want to arrange the data of each of these leaf into the ascending order. So let's look at an example. Want to look at an example to illustrate what we have just discussed and see how we can have the stem and leaf drawn to our attention. But one thing I have told you, you have to understand what are some of the advantages of a stem and leaf over a histogram, because we have talked about the stem and leaf and we have been trying to relate it with a histogram. We have not seen how a histogram is drawn, because that's going to be our next video, talking about the curves, because here we have just talked about the charts or the graphs. We have not yet talked about the line and then the curves. Then from there, that's where we shall have the frequency polygons and other aspects. But one of the advantages that we said that is very important for stem and leaf is the fact that it retains its original data, the original data values. And of course, when you are drawing these histograms, for them, they lose those values, because when you are drawing the histogram, we do what we call grouping. We group the data into different intervals, which we don't do under the stem and leaf. And the other thing is that this stem and leaf is constructed more quickly and easily as compared to the histogram, plus even its interpretation. Then lastly, of course, we understand that the stem and leaf, it gives a detailed analysis, because you look at the individual values that you have retained in the diagram. Then you can be able to identify the different figures, such as the outliers and so many figures. That is in terms of making the analysis. So let's look at the example. So we are saying at an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. Full stop. Construct a stem and leaf plot for the data. So let's now look at the data set that has been given to us in the question. We are going to write them in rows and columns as if they are matrix, just like the way we've been presenting our data set. So let's start with 25, 14, 36, and then 32. Then you have 31, 43, 32, and then 52. Have 20, 02, 33, then 44. The other we have 32, 57, 32, and then 51. And lastly, we have 13, have 23, we have 44, and finally 45. So those are the values that we have, and they want us to use that information to draw what we call a stem and a leaf. So let's go ahead and look at the different steps that we saw. We go through those steps so that we can be able to draw a stem and a leaf. The first step we said we are going to arrange the data set in order. Arrange the data set, arrange the data in order. And we said that this order should actually be an ascending order, because you saw the last step is talking about arranging the leaf or the leaves in what we call an ascending order. So it's better we also go by that aspect. Now, as you are arranging this data set, you do two things. Maybe let's first arrange, then I will show you what else to do. But just know when you're arranging the data, we do two things. The first thing is to arrange the data in the normal way, from the smallest to the largest. So within the values, if you try to cross-check the data that we have, we can see that we have 0.2 here. 0.2 as our smallest value. Then our biggest value, of course, if you peruse through, you can see that we have a 57 here. So now we have seen where we are supposed to start from and where we are supposed to end. But we write what is missing, like we don't have a 0.3, so 0.3 will not appear anywhere. We arrange based on how those values are. So we start. We have a 0.2. If they have given it to you as a 2, take it the way it is. 13, we have a 14, have 20, we have 23, we have 25, we have 31. These values, I arrange them based on how they are, according to how they are given, how they were given to us. We have 32. We also have 32 second time. We also have 32 third time. We also had 32 for the fourth time. Then the next one is 33, 36, 36, then 43, 44, then 44 again, then we have 45, 45, then 51, 52, and finally 57. Now, that is our first arrangement. We are still arranging the data. Now, then within the same step of arranging data, what we do next is that we separate the data. We separate the data according to the first digit or the leading digit. We separate the data according to the first digit. According to the first digit, or what you call the leading digit. The leading digit. That is very important. It's not so much important if you have mastered, but it's one of the steps, or one of the fundamentals for you to be able to have this data, especially if you are not going to go into the last step, the step number 4. Because remember, we said in the step number 4, we arrange the leaf based on their ascending order. So let's now arrange the data according to the first digit. Now, if you are to arrange the data according to the first digit, the first digit above, we saw it was 02. That was the first individual value. That's a value or an observation is a 02. But the leading digit is in that 02 is a 0. So we start with all numbers that have their leading first digit as a 0. We first arrange those. Then we also have these are like we are forming classes whose leading digit are the same. Like for a 0, numbers that have a leading value as a 0, we only have one individual digit or individual observation. So it will be 02. So to separate this from what we did up there, here let's not put, if we have only one value, let's not put a comma. We only put a comma when we are separating the first digits themselves. So for this one, it is a 02. Then we go to the other number that has a leading value as a 1, because now we are counting in an ascending order. We are taking whole numbers. So when you move from 0, the second value is going to be a 1, a 2, a 3, a 4, a 5, a 6, 7, 8, 9, then you go to 10, 11. Those are the leading values. So now when you go to 1, there are only 2 digits that start with a leading digit as a 1. It's only 13 and then 14. Those 2 observations, they are the ones that have a leading 1 or a leading digit as 1. So we put 13. Remember, we are just separating the individual observations. 13, then we put a comma because there are many numbers. Then we give the 14. Now we skip, because there are only 2, we can now skip a space. That space is just to classify. We are classifying values according to their leading digits. Now, the third leading digit is a 2. And we have seen that we have a 20, 23, and 25. Any leading 2 in all these individual observations that we are given to us will be grouped in that same category. Those are the ones that we call groups or classes. So we are not going to put a comma here. We start with a 2. We just leave a small space. 20, 23, 25. There are only 3 individual observations that are falling in a class with a leading digit as a 2. Then you go to a leading digit as a 3. How many values are there? We have 31 up to 36. So we also leave a space. We say 31, 32, 32 again. Even if we had 132s, we would all write them, all of them, and you will see how we shall be writing their leading digits and then the leaf. So 32, that is for the second time, because they are fourth. This is 32 for the third time, then 32 for the fourth time. And then we go to 33, then we go to 36. So those are the ones that have a leading value or a leading digit, not a value. A value can be, they can be 2. It can be a 12, that's a value. A single value as 12. But here we are meaning a digit, meaning one digit. So we go now to the other class that will have a leading digit as a 4, because we have moved from 0, 1, 2, 3, 4 in an ascending order. That's why I was telling you the ascending order is very important. So we leave a space. We write now those that are starting from 4. So this, we have 43, comma, we have 44, then 44 again, comma, we put 45, comma, of course they end on 45, so we said we are not going to put a comma here, so they are stopping on 45. Then we go to those values whose leading digit is a 5. So they are only from 51 to 57. We have 51, comma, we have 52, and then 57. So these are the ones that we call the groups. These are the groups that we are talking about. That's a group. Also, this one is a group. This one is a group as well. This one is a group. Even the whole of this is a group up to this point. And even the one that we have left in the middle is also a group. So that kind of groupage, that kind of grouping, that's the second layer that is within that first step. Now, once you have grouped this value, the next thing that we are going to do is to display these values. How we are going to display these values? We go ahead in the second step, we go ahead to distribute these values into what we call a leading digit as a stem, then a trailing digit as a leaf, because these are only 2 values. There are 2 digits in one individual observation. This is a 0 and 2, then 1 and 2, 1 and 3. There are only 2 digits in that individual value that was given to us. So it means we only have 1 leading digit and then 1 trailing digit, meaning the leading digit will be the stem, then the trailing digit. In other words, the digit that comes at last will be our leaf. Just like the way we've seen, if let's say we have this 20, if we have a 20, then the 2 will be the stem or the leading digit, and then this 0 will be the leaf. If it is 14 or 13, this one will be a stem, then this 3 will be a leaf. So we need now to see how we construct this. Of course, the other steps, they are for us to write the stems from the smallest to the largest. But how are we going to pick the stem? We have seen that the stem will be that leading digit. But we said these leading digits are going to be on the left of the vertical rule. So we are going to draw a vertical column, a vertical line, just to separate. This is what you draw. You just draw something that looks like a T. In accounting, we call that a ledger, a T account. So on this side, you put, we are not going to call it stem, but we are going to call it a leading digit so that you get the concept. But just know the leading digit. Maybe you can put it in bracket stem, because we say the stem is always on the left hand. Then this side we have the trailing digit, what we call the leaf, on the right hand side. So we then go ahead to put in the values. Now, as I told you, we move in the ascending order from the smallest to the largest. So the values, the stems that we have, we are going to record them vertically. So we start with, of course, we have a 0, we have a 1. Let me make sure that these values are in line. That is a 0. Remember, we are moving in an ascending order. 0, 1, 2, 3, 4, 5, because they are ending at 5. Now, we are starting now to draw what we call the leaf. Of course, now we go to step 3. The step 3 is for us to have the leaves. So we write each leaf. Now you see, we grouped these according to the values. Here we had a 2. So that when you remove this vertical line, it becomes 0, 2. Then we go to 1. When you go to 1, the first value was 13. So the leading is a 1, then the leaf is 3. So we start with the 3. But there are 2. So the 13 and the 14. 14 is the one that follows. We put a 4. So that if someone reads, he can read 1 and the 3, and then 1 and the 4. Meaning there are 2 values, but they are going to be in ascending order from the smallest to the largest, going that way. That's what they are talking about in step 4. That when we are writing these leaves, we make sure that each leaf is going to be arranged in an ascending order. So we go to now the leading digit as a 2. We had 20 to 25. We had only 3 digits. So the 20, it is a 2 as a leading digit, then a 0 as, so this is a 0 for a leaf. Then we also had a 3, that is 23, so we write a 3 in here from 0, 3, then we had 25, so we write 5 as, so we started from the 0, 3, 5, because from the smallest to the highest. The reason as why we do that is because we said that this diagram helps us to get a range, and we'll be able to get both the minimum and the maximum values. We can get the maximum and the minimum values in that class depending on the leading digit. So we go to a 3. A 3, we are supposed to move from 31 to 36. Now, we have seen that we have 31, so the 3 was a leading digit, and then we are taking a 1 as a trailing digit. So this one is a 1. The next one, we had 32 4 times, meaning there are 4 trailing digits within that class as 2. They are all 2s. So the first 2, then the second 2, the third 2, and then the fourth 2. Because we are writing it in the ascending order, then we go to the next digit, which is 33. 33 was appearing once. So we picked the 3 to be a leading digit, and then the 3 to be a trailing digit. Then lastly, we had 36, and we picked a 3 to be a leading digit, then a 6. So if someone is reading, it will be 3, 1, 3, 2, 3, 2, 3, 2, 3, 2, 3, 3, and then 3, 6. If these values are repeated 10 times, we write those values, those 10 times they are repeated. Don't say I've seen 20, 32, then you write only one value. Because I told you the stem and the leaf helps us to know which number has been repeated more times. So we can see that the 32 was repeated more. It was repeated 4 times. So that will be our mode in this kind of scenario. So we go to a 4, our leading digit as a 4. We had 43, 44, 44, and then 45. So we took the 4, the leading digit, to be a 4, then 43, 44, 44, then 45. Then lastly, for the 5 as the leading digit, we had 51, 52, and 57 as the individual observations. So this is 5, 1, the 2, and then the 7. And of course, that's how we present the stem and the leaf. Now, the other thing that they may ask you from this, remember we said we may have values that are going to be coming to you as the questions Of course, if you look at this distribution, we can see that this figure, we are seeing that most of the values are concentrated in the middle. That's the shape of the distribution. So the distribution shows that it peaks at or it peaks in the center. And then the other thing is that we don't have gaps in the data set. Having gaps in the data set means that maybe within these values, you may find that here, let me maybe use a different color. You'll find that maybe some of the leading values were maybe 0, let's say 2, and then 4, and let's say maybe here we never had any value, and there may be like that, like those ones. Even if we just put maybe 8, but you happen to come to this leaf and you find that some of these values, some of the values are missing. So if you are looking at this distribution, you will find that from 0 there is a 1 that was missed, that was missed. Then from 2 there is a 3 that was missed. Then from 4 then they went to 8. So in between there are values that are missing. In other words, you can see that we don't have values to do with the 10 up to 19. We don't have those values, but we have those that are starting maybe from 20 to 29, but we don't have those that are starting from 30 to 39. So those are the gaps that we are talking about. So as we are describing this set of data, depending on the values that have been given to you, you can see that here we don't have gaps in the distribution. But the other thing that we have noticed is that it is very steep here. If you are to draw a curve like this, it shows that this side it is very steep. It is steep, or it peaks in the center, because this can be the center of the data set. With these two, you can see that the data set is peaking in there. If you are to draw maybe a frequency distribution. Now, of course, they can also ask you to explain the steepness. Of course, if you look at, they told us that these were days that they did the cardiograms, and you can see that majority of the people are within 30, they are within 31 to 36, because that's the one that has the highest. 1, 2, 3, 4, 5, 6, 7. There are 7 people from 31 to 36. There were 7 number of patients who received their cardiograms between 31 and 36. So the plot also shows that the testing centers treated at least like the minimum of 2 patients. They treated a minimum of 2 patients because we started from 0 to, meaning we had a minimum of 2 and then the maximum of 57 patients in that time frame within the 20 days they carried out. Now, there is one other thing that I need to highlight on this same aspect. let me show you, let me assume that here we had a leading digit as, let's say, 8, but maybe we had only one individual value and it was 80. If there are only one item, now we've picked the leading digit as 8. Here we can't write a 0, even if it is just one digit. But if this 0, just if we had maybe 2 digits that were in within the 8, maybe 80 and then 81, then we would write that first 0, then we put a 1. But if it is only 1, then it is better to write the leading 8, then in the trailing digit we don't put anything, because that would mean that it is a 0. It is the same thing like if they don't give you the leading 0, if in this question they just gave us a 2, like 2, it's okay to take this 2 this side as our trailing digit, then we leave this one empty. It would mean the same thing, because that empty space, as long as either side has a digit, we assume that there is a 0 there. So that's basically what I wanted to highlight as far as this is concerned. But maybe just for, we can have something small. We said here we have the stem. Even if you just say stem and the leaf and you don't put the leading, we want to look at a situation where maybe we have many leading digits, because we have not seen that. We've just looked at when they are only. Maybe you can have like 5 or 6 digits here, and we know how we can present this. If we have been given information that is in hundreds, can have information maybe 325, comma, then 327, maybe 330, then 332, comma, then maybe you have 335, then 341, 345, and finally we can have 347. Of course, I've given you this value when I've arranged it, just to simplify our work. So the big question is, how do we take this? What will be our leading value? So we can also mix in some, maybe one that is in thousands, maybe 4, 3, 3, 5, as those are our values. So of course you will look at that 4335 as an outlier based on the figures that have been given to us. You can easily identify that this is an outlier. So we just want to take this information. Now this, from this first one that is in thousands, the 433 will be our leading value. Then this last 5 will be the leaf. Then from these that are in thousands, it is these first two that will be our stem, then this last one will be our leaf. That's what we meant, that we can have leading digits or many digits as the stem, then the leaf is only one digit. So we can transfer this information based on that knowledge. We take this information to our graph. We take the 32, because we had 32, those were all in 30s, 32, 33, we had 34, and then the other 4, 3, 3. Then we come and complete these other values. The first one was 3, 2, 5. So we put our 5 this side. Then 7. There were only 2 values. Then for 3, 3, we had, now here we had 3, 3, 0. So the 0, we don't write it unless we have other values that are not 0. So this 3, 3, 0, it had a 3, 3, 2. So this 0 is supposed to be written because there is a value of 3, 3, 2. Then 3, 3, 5. Of course, the 3, 4 as the leading digit or the leading digits, they had a 1. Then we had a 5. And finally, a 7. Then for the last one, we only had 1, 5. So in every observation, you pick only one leaf. So that's the differentiating feature that we talked about, of having very many digits, as you can see, in terms of the leading digits, but we're supposed to have only one leaf. So that's all I wanted to talk about as far as the stem and leaf are concerned. But be mindful of the advantages and then the disadvantages of that. Of course, there are other charts that we have not looked at. We have the Pareto chart, but maybe to just give you, because Pareto chart is more of a graph or a diagram. And remember, we said that this was going to be our last one. So if you're looking at the Pareto, let me just explain it here. Pareto, the one we use here, we get the information, we also arrange the difference. I'm giving you the difference and how it's drawn. We arrange data in descending. This one we arrange in descending order. We arrange in descending order from the largest to smallest. Then we plot. That's the only thing, that we start by plotting the highest, followed by the smallest, and until you finish all the data set. So that's the key difference with the Pareto chart. We shall have situations where we have very many information, but what you have to understand with this, you just have to draw your axes. You draw the x-axis and then the y-axis, then you draw the bars. Of course, you are going to get these values. You are plotting the numbers against the frequency. They may give you numbers, or they may give you countries, they may give you months. So depending on what they have given to you. So you draw, then you, of course, this will be our y-axis. They may be, but we call them frequencies. Here they may give you months, or they may give you countries. So it depends. We can say months. Then you start with the highest. It will move like this until you draw the last one. Of course, as you are explaining, you just pick out the, if these were months, you pick out the month with the highest value. If there are countries, then you also, but as I told you, the bars have to be the same. The big point here is to arrange the data set from the largest to the smallest. And the last part is that we don't actually put spaces. So we are now going to look at the curves, where we shall talk about maybe some line graphs or time series. Then we look at because my target is to pick out the curves, and among the curves that I'm more interested in, we have the ogives, then we have histogram. The reason why I brought this histogram as if it is the last is that it has more steps that we should go through, and which is, of course, these two, they are the ones that are most examined. Of course, you can also put the frequency polygon, but that's all as far as the graphs are concerned. So for those who want to join our CPA recorded lectures, both classes and then the revision classes, the payment is just 200,000 Ugandan shillings, and you'll get access for 12 months from the time of payment. So if you pay today, you'll get access to those recorded lectures up to the time when the 12 months elapse. So that's all for today.